Hello and welcome to this episode of Math with Martinez. We are continuing our look at the learning goal of determining the quotient of a polynomial by long division and synthetic division. In our last video, we worked at being able to find that quotient using long division. And today, in this video, we're going to be looking at using synthetic division. So this page right here is going to be really nice to look back at as you are working through synthetic division independently. And I'm going to use these examples down here, these examples 5 and 6, and flip back and forth between these two pages following the steps that you'll see right down here. So let's go ahead and begin. If we're going to use synthetic division, it really is just another algorithm like that of long division. What we'll do is we're going to start by wanting to identify what is, if I were to look at my divisor, what is the zero that would correspond with that? What is the zero that would correspond with that? Well, that zero right there is going to be, the zero is going to simply be found by taking and setting that binomial equal to 0. So that is a -2. That's our 0. Then once we find our 0, we're going to go ahead and put that in this little box, here, in front of where I'm going to list out all my coefficients of the polynomial that I'm dividing. So check this out. So in the little box, I'm going to put my -2. And then I'm going to look at my coefficients of my divisor, my dividend here. So what are those coefficients? The first one is a 3. The second coefficient is a -1 because it's negative and I don't actually see him, but I know he's there, an almighty 1. And then last of all, a -20. Leave yourself a little space between where those coefficients are and where you draw that horizontal line, because now it's time to follow the next step, which is step number 3. Bring down that first coefficient. Bring down that first coefficient. And then, like we do with long division, we're going to do a bit of multiplying. We're going to multiply this value that's out here, this little 0, with the value that we brought down. -2 times 3 is a -6. Then we're going to add those terms in the column that we just created. That is a -7. And then we repeat the process again. -2 times -7, that's going to be a 14. And then once again, we add in this column. That's going to give us a -6. Okay, so now we finished that. Now we're going to use the final numbers. We actually just did 5, 6, and 7. Use the final numbers to write out your polynomial. Okay, so this last term right here is always our remainder. Whatever is at the end is our remainder. So I know that I have a remainder of -6, and that's going to be over what I'm dividing by, which was that k plus 2. I'm going to kind of put this negative out in front because we don't assign the negative to like the numerator. It's just that the fraction is negative. Okay, so if that is the remainder, then the term right next to it, that -7, is the constant term. And then if we bump up the power just one more, then that means that this is my linear term. So it's 3x. So these values here are the coefficients, right? And so we needed to, oh, it's not x, it's a k. We need to add back in our variables once we've found the coefficient values. So let me do that again. Let me look at this next one with you all. Let's box this up and use some synthetic division for this one. So we want to start by figuring out what is the 0. What is our 0? Well, we just want to find it by going ahead and setting our divisor equal to 0. Solving it, it is -5. So -5 is going to go in the box, and then I'm going to take all of my coefficients, and those are going to go right here. Okay, those are going to go right there. The first coefficient, the coefficient of my cubic term is a 1. Of my squared term is a 2. My linear term is a -22. And then my constant is -45. Now, if you would have been missing any one of those terms, like in descending order, you just want to fill it in with putting that you have 0 of them. Okay, draw the bar, bring down the first term. Then we multiply. Then we go ahead and we take this value. Let me highlight it here. We take this value and multiply it with what we just brought down to figure out what goes in here. So -5 times 1 is a -5. Add in the column. That's going to give us a -3. And then multiply again. Negative and negative is going to make that a +15. And so -22 plus 15 is going to be a -7. Then once again, we're going to want to multiply -5 and a -7. And what's that going to be? That's going to be a 35. And it's going to be positive. And then we want to add. And so what is left there is a -10. Again, I like to circle this and remind myself that this is the remainder. So I'm going to take my remainder of -10. I'm going to write it as subtracting 10 over what I divided by, which was x plus 5. The -7 is our constant. My -3 is my linear term. So add, that would be linear. So just x, no power, just x to the first power. And then next to that, that 1, bump it up one more time. Whoops, sorry. Bump it up one more time. Now this is my squared term. You see how it's just increasing in powers there? Increasing in power from constant to linear to squared. Now I don't actually have to put that 1 in front when I write my final answer. It is understood. So ladies and gentlemen, there is the result of my division. That is the quotient using synthetic division. Your choice. They both work equally well. You can use long division or synthetic division whenever you're asked to divide your polynomials. That's it for this video. If you guys had any questions, please take a moment to share those now. And until next time, stay fired up.